We talked about multiplying radical expressions yesterday. Let's look at dividing them. This first example, the first thing you should always ask yourself is, can I simplify the radical first? So in this case, both of these are perfect squares. So this is simply 5 over 4. Okay. Now B, on the other hand, those are not perfect squares. So we need to see, can we simplify the coefficients in front? Okay, at this point, no. 3 over 2, can't simplify that. Can I simplify what's under the square roots? So as long as they're both under a square root here, we can simplify them. So 6 and 15 are both divisible by 3. So we're going to start by dividing both of those by 3. Now, we're still stuck. 2 is not a perfect square, 5 is not a perfect square, so we have to resort to what we call rationalizing the denominator. So to do that, we are going to multiply top and bottom by the square root of 5. I don't multiply the 2, just the 5. So on the top, we get 3 square roots of 10. Remember, multiplying, we multiply what's under the square root. And on the bottom, the square root of 5 times the square root of 5 is the square root of 25, which is 5. So this ends up giving us 3 square roots of 10 over 10. The only thing that we might possibly be able to simplify here would be the 3 over 10. And we can't, so we're done. Okay, that's it. You can't simplify the 10 over 10 because one of the 10s is a square root of 10. One of them is just plain 10. So we can't do anything there. All right, so here are some practice problems. Pause the video for a second. Work them out, and then come back for the solutions. Here are the solutions to these two problems. And then I need you to pause the video and do these practice problems on the worksheet, 62 through 70 even. Okay, we can also rationalize higher order radicals. So for example, a cube root. But the key here is that we've got to turn it into a perfect cube. So let's just look at this first example here. First thing that we should ask ourselves is, can we simplify what's under the radical? Well, in this case, we can. 125 is a perfect cube. So let's simplify that. We can't simplify the cube root of 2, so we'll just leave that. The cube root of negative 125 is negative 5. Negative 5 cubed is negative 125. So it took care of the problem itself. We really didn't even have to rationalize. Actually, hang on. Let me erase that for a second. I'm talking instead of focusing. We can cancel those 5s. So, and we don't like to leave negatives in the denominator. So this is the negative cube root of 2 over 3 is the final answer here. Okay, we didn't even have to rationalize in this case. Now, on the next example, we are going to have to rationalize. So the cube root of 5 over the cube root of negative 25. Now, let's make life a little bit easier on ourselves. Since those are both under a cube root, we can start with simplifying just that itself. So both of them are divisible by 5. So in the numerator, if we divide that by 5, we get the cube root of 1, which is just 1. And in the denominator, when we divide that by 5, we're left with negative 5. Now, we can take the cube root of negative 5. We can get rid of the negative. We can take care of the negative. But let's not worry about that right now. Let's focus on, we've got to turn this into a perfect cube because we have to be able to take the cube root of this number. So to turn 5 into a perfect cube, we need to multiply it by 25. The cube root of 25, because what that's going to get us here, and I'm going to take an extra step to write it out, we've got the cube root of 25 on the top, and we have the cube root of negative 5 times 25 is negative 125. We just dealt with that. Negative 125 is, the cube root of that is negative 5. We don't like negatives in the denominator, so we just slide it up in the numerator in front of that cube root. Okay, we cannot simplify any further because the 25 is under the cube root, the 5 is not. You can check these, all right, just like we've been able to check all the rest of them. Type it in, the cube root of 5, make sure you close your parentheses, divided by the cube root of negative 25. Get its decimal, and then type in your answer. Negative cube root of 25, close your parentheses, divided by 5. Exact same number, okay? So that's rationalizing higher order. You got to turn it into a perfect cube, or if it was a fourth root, you'd have to turn it into a perfect fourth. So there's one, actually, to practice with the fourth root. So try and rationalize these two, pause the video, work them out, and then come back for the solutions. Okay, here is the rationalized version of A and B. So look at the work there if you didn't get the exact answer, and talk to somebody next to you if you need some help with that. And then I want you to practice with the worksheet 72 through 78 evens. So pause the video, come back in a minute to see one more thing that we need to deal with dividing. Okay, so rationalizing using conjugates, okay? So these examples are a little bit different than the ones we were just doing because it doesn't have just a single square root in the denominator. It's got a binomial term, and in this case, both parts of the binomial are a radical. So this is why we talked about multiplying conjugates, because that's what we're going to do here. The only way to get that square root out of the denominator is to multiply top and bottom by the conjugate. Okay, multiply top and bottom of the conjugate. So the conjugate keeps everything the same, it just changes the sign between the two square roots. So at this moment, I'm not going to multiply out the numerator because maybe I'll be able to simplify with what ends up being in the denominator. So we've got to FOIL this. Square root of 3 times the square root of 3 is 3. Remember, the deal with this was the outside and the inside cancel. We get positive square root of 6. Well, let me just write it out. Positive square root of 6 minus the square root of 6 minus square root of 2 times the square root of 2 is simply 2. So in this case, they do cancel out. In the bottom, we get 3 minus 2. That's 1. So this ends up just being 5 times the square root of 3 plus the square root of 2. Now, I prefer to leave it in factored form, but it is equivalent. You can just distribute that 5. Okay, and these are the same. All right, they are the same. Again, you can check it if you want to in the calculator. Just make sure you're careful with parentheses. 5 over, you got to put the whole denominator in parentheses. Square root of 3 minus the square root of 2. Close your parentheses, run the whole denominator. And then type it in, 5 parentheses square root of 3, close it for the square root, plus the square root of 2, close both of those. Okay, equivalent decimal approximations. Now, the conjugate, you don't always have to have 2 square roots. Okay, it doesn't always have to be a square root plus or minus another square root. In this case, we've just got 1 square root in that denominator, but we still approach it the same way. We still are going to multiply by the conjugate. Now, the conjugate only changes the sign in between those two terms. It does nothing to that -1 right there. It only changes the sign in between them. And again, I'm not going to multiply out the numerator right now. I'm going to leave it the way it is because hopefully, maybe, we'll end up simplifying something here in a minute. -1 times -1 is +1. The outside and the inside cancel. I'm not going to write it this time. -4 times +4 is -16. Square root of 5 times square root of 5 is 5. So we've got to multiply that out here. And the last one, we didn't have to worry about that. So we've got 1 minus 16 times 5 in the denominator. That's -79. We don't like let's see, is 3 over 79 reduce? No, it does not. Okay, so let me write out what we've got right now. We've got 3 times -1 plus 4 square roots of 5 over -79. We don't like negatives in the denominator. And I am going to go ahead and distribute that. I'm going to move this negative right here with the 3. And I'm going to go ahead and distribute it. So -3 times -1 is +3. -3 times +4 is -12 square roots of 5 over 79. Okay. They may leave it in factored form, they may multiply it out. You just need to know that those two things are equivalent, and we don't like to leave those negatives in the denominator. Okay, so here's some practice. Pause the video. I gave you an extra one here because I want to make sure you've got it. So pause the video, try these, and then come back to see the correct answers. Okay, here are the correct answers for these. See if you've got any questions. And then finish out the worksheet there, 80 through 92, every other even. And if you got some extra time, just go back and do some of the problems we haven't done yet. I promise you, you cannot practice too many of these problems to get this done. And let me flash up the answer key to the whole worksheet here so that you can check those out and see if you've been doing this right. So here are the remainder of the answers that we haven't done so far, so you can pause the video and check whatever you need to check.